Good day to all. We are in the eighth lecture for the yarn spinning cost. In this, we are going to continue the calculation for power cost. We'll look into the detailed calculation of UKG and power cost per kg in this lecture. As we already know that the various components of the cost in the yarn spinning mill are material cost, labor cost and power cost. The second largest consumption is power and the third is the labor cost. This table is from the Citra norms 2020. We can see that the power cost is the second major component of the total cost, and we can see it ranges from 10 to 20. The lowest is 11.8 for 30s count, and it is highest for hundreds combed. It is 18% of the total cost. So we can see that the power cost has to be taken into account. So let us go into detailed calculation of UKG, power cost per kg of yarn, along with the production and waste calculation. In the last lecture, the production required for 100 kg of yarn production was already given in the question. Today we'll look into a different problem. The question is to calculate the number of units per kg of yarn, that is UKG, in a modern spinning mill with the given details. So the given details are the number of spindles is 1000 in a frame, GPS is 105, count is 40, yarn realization 72%, and it is working for 8 hours per shift. The power cost to be paid per unit is rupees 6.5. One assumption has to be taken here, which is the units consumed for 1 HP machine if it runs for one shift of 8 hours is 4. Units consumed for 1 HP if it runs for 8 hours is 4. This is an estimate which these calculations are followed by Citra as well as Saima in South India. So this will aid in proper calculations. The other given data are the departments, various production departments, waste percentage in each department, production per machine per shift in each department, and the HP of that particular machine. So we have the various departments from blow room. We have the card, superlap, comber, draw frame breaker, draw frame finisher, simplex, ring frame, and auto corner. The waste percentages of the various production departments are given here. Now, blow room 5%, carding 4, comber 16, draw frame breaker finisher both 0.25, simplex 0.7, ring spinning 3.3, auto corner and 0, and the last is the indirect power. So there is nothing related to waste. It is actually not applicable. And next is the production per machine per shift in kgs is given here. So it is these values. And next is the machine HP. So we have the HP of the machine given. Blow room machine HP is 120. In the last problem, we saw the direct units given for 8 hours production. Here machine HP is given, so we need to calculate the production per machine per shift based on HP, for which we have an assumption. If 1 HP works for 8 hours shift, then the units consumed is 4. So with this assumption, we have to calculate. So we have the indirect power, it is taken as 80 HP totally. So let us go into the solution, for which we need to go first calculate the production at the ring frame for the GPS that is given in the question. So the production required in ring frame is for in grams is given. GPS is already given, so we are writing that one. And so for 1000 um, 1000 spindles, then it is 105,000. So it is nothing but the number of spindles into GPS. So it is already given 1000 into 105. So it is 105,000 grams. We have to convert this into kgs. So this is the production required at ring frame in kgs 105. Next, we need to find how for this production what should be the input at the ring frame so that we can see the production required at each department using the waste percentage can be calculated. So the way we for which we need the waste multiplier. Waste multiplier can be found out from the yarn realization which is already given in the question. So waste multiplier is actually 100 divided by yarn realization. So 100 divided by yarn realization 72, we get 1.382, which is the waste multiplier. Production required in ring frame into waste multiplier, we will get the raw material required to be given as input in mixing. So it is nothing but production required at ring frame into waste multiplier. So 105 into 1.389, we get 145.83. So this is the input in the loader. So let us go into the calculations now. So we have the various uh, production departments. Department blow room, carding, superlap, comber, draw frame, breaker, finisher, simplex, and auto corner. So we have calculated the input. First calculated value is 145.83 kgs. We have to put the same here. So already given in the question is waste percentages. We have to write the same. Waste percentages are given in the question here. This is already given. This has to be put here directly. So we have that auto corner. So we have to calculate the output kgs of each department. And we have to first of all enter the output because we know that we need a ring frame production of 105. So we have to directly write that because while calculating, we on accounting for invisible losses, we may go into a wrong calculation. So we have to write this first and the same in the ring auto corner. And next one data that is given as production per machine per shift is already given in the question. This data, this has to be written here, the production per machine per shift, and we have to calculate the number of machine shifts required. In the last problem, in the last lecture, we saw this data already given. So we have to calculate this. This is equal to input. This input which we are going to calculate divided by production per machine per shift. So we need to calculate that. And next we know the machine HP. So and with the number of machine shifts required, machine HP, we can calculate the number of units per 1000 spindle shifts or units required for 1000 kg. So let us go for this particular GPS. So what is that required? So we know the input from the waste percentage. We can calculate the output, which is input minus input divided by input into waste divided by 100. So input minus waste is your output. 145 minus 145.83 into 5 by 100. We get the output. So similarly, that is the input for the carding. Similarly, calculate the output for carding with 4% waste. 138.54 minus 4 by 100 into 138.54, we get 133. This is the input for superlap. Since it is 0, we get the same output. Next is comber input 133. So output is 133 minus 133 into 16 by 100. So we get 111.72. Draw frame breaker input 111.72. So output is 111.72 minus 0.25 into 111.72. We get 111.44, which is the input to the draw frame finisher. This in minus 111.44 minus 0.25 into 111.44. divided by 100, we get 111.16. This is the input to the simplex. 111.16 minus 0.7 by 100 into 111.16, we get 110.38. And next, this is the input to the ring frame. Output we have already written, but if we calculate, we will get this answer 106. Accounting for this waste percentage, we will get 106. This is for 1008 spindles. So for 1000 spindles, it is 105. And if it is invisible loss, it is this much value. So we should not take those things into account. For this much GPS, we have to write the production here directly from the first calculated value with GPS. So let us next go on to the number of machine shifts required calculation. Number of machine shifts required is equal to input. Usually we take output by production per machine shift, but here we consider input so that we will take into account the total power consumed. As the total input is given inside the machine, we take input for this calculation. So input 145.83 divided by 2000, we get 0.073 number of machine shifts required. Similarly here, 138.54 divided by 350.386. Next, 133 divided by 320.416. Next is 133 divided by 450. And next is 111.72 divided by 750. Next is 111.44 divided by 800. And next is 111.16 divided by 440. Ring frame, as I already said, it is already highlighted in blue. In here, you should not calculate anything. These things have to be totally removed, and you have to directly put the required here, the required production, which is the GPS, because we are calculating everything for the this GPS. So this is the actual production, and for 1000 spindles, it is for 1000 spindles. The machine may have 1200 anything, but we are going to calculate only for 1000 spindles. So here it is the number of machine shifts required to produce this GPS is 1. So it is 1 here. So we have to be very careful here, not like the other calculations. Here it is a different thing. So let me highlight that it is a different thing here. Then again, it is the same for the auto corner. Okay. So it is the same for auto corner. So auto corner, it is the same 105 and it is 470. We have 105 is the input here, and we assume that there is zero wastage, and so it is 470 here, and so the 105 divided by 470 is this much, 0.223. So this is the number of machine shifts required for the particular GPS. Here it is 105 for 1000 spindles. So let us calculate. So we here, because we are calculating per 1000 spindle shifts. The machine may have higher capacity, but 1008 spindles or 1200 spindles. But here we are calculating the units per 1000 spindle shifts. So then the machine HP for the various machines are already given in the question. See, we have here just pasting copy and pasting the values here, the machine HP for the various departments: blow room 120, carding 10, superlap, comber and all. Finally, we have here the calculation for the units per 1000 spindle shifts. We know how many machines are required for the required production of 105 GPS. We have the machine HP. Now machine HP into number of machine shifts required into 4 will give this answer here. So this is 0.073 into 120 into 4. We have this here. I'm showing we can have this here. It is 120 into 0.073 into 4. Why 4? Because already we have the assumption given here in the question. The units consumed for 1 HP for 1 shift here. The assumption is already given. This is the usual assumption taken by the industries. This is the thing followed by Citra and South Indian Mills Association. They use this in the calculations. Similarly, we also use it is an estimated value, not just simple assumption. This assumption is based on an estimation. Okay, so again we can see the same calculations for the other things also. So for the carding, we have the same is equal to 10 into 4 into 0.396, which is 15.83, and next is 10 into 0.416 into 4. Similarly here we have 16.63, then 10 into 0.296 into 4, we get 11.82, 8 into 4 into 0.149, we get 4.77, 8 into 4 into 0.139, we get 4.46, 15 into 0.253 into 4, we get 15.16, 60 into 4 into 1, you get 240 units, and 30 into 0.223 into 4, you get 26.81. So now let us sum this all the units. So this is the units, total units per 1000 spindle shifts for 105 GPS. Okay, so summing all these values, we get the total units, total direct units. Okay, we have the total direct units here. So we already know the indirect units. We have the total indirect units that is already given in the question. So we have the total indirect units consumed to be 80. So this can be added here directly. This is for the lighting, humidification and others. So direct units total is 370. Total indirect units is 80. So the total units consumed for 105 GPS per 1000 spindle shifts is 450.47, which is the total of the direct and the indirect units. We have already been given in the question the power cost per unit is 6.5. So it is already given. The power cost is 6.5. This is given here. You can see in the question. So the units, power cost units that has to be paid for government is 6.5 per unit. So we have that here. So the total power cost is power cost per unit into total units consumed. So the total cost is 6.5 into 450.47. So that is 2,928 rupees. This is the total cost in rupees for 105 GPS per 1000 spindle shifts. So power cost per kg is equal to total cost divided by production in the ring frame, which is 105 kgs. The total cost is 2928. So we get the value 27.89, which is the power cost per kg. The units consumed per kg is equal to 4.29, which is the total units divided by the production. 450 divided by the production, ring frame production 105, we get the UKG. This UKG as per CITRA norms rating for this UKG is average. Okay, this is an average mill. If the units consumed is 4.29, then it is an average mill. Thank you.